Welcome to This Explainer. I am so thrilled you're here today because we're going to go on a completely fascinating journey back in time. We are unpacking the origins of a subject that every single one of us has encountered. And yeah, usually with a mix of awe and, let's be real, maybe a little bit of dread. I'm talking about algebra, but we aren't just looking at math today. We're looking at an absolute masterclass in problem solving and structure that literally changed human history.
So I want you to take a second and just imagine a world where solving even the most basic equations was incredibly difficult, if not totally impossible. Imagine a frankly chaotic ancient world where there were no algebra textbooks. Every single math problem you encountered in your business or just daily life was this unique, frustrating puzzle. There were absolutely no universal methods, no standard rules to fall back on. Basically, you had to invent a brand new way to solve a problem every single time you faced one.
And honestly, it gets even wilder. Think about the equation x plus 5 equals 12. This simple, modern string of mathematical symbols simply did not exist anywhere in the world. No way. You can just jot this down on a piece of paper and solve for x. The very concept of symbolic equations was completely unknown. Okay, let's dive into this. We're going from mathematical chaos right up to the modern classroom. First, we'll look at a world without algebra. Then, completion and balancing, organizing mathematical chaos, math for the real world, doing it with no symbols, just words, and finally, the incredible legacy of Al-Jabr.
Starting with Part 1, A World Without Algebra, and the 9th Century Problem.
To actually understand the solution here, we have to travel all the way back to early 9th century Baghdad. This was during the Abbasid Caliphate, a massive, bustling hub of global trade that desperately needed reliable math for things like taxes and land measurement. Enter our protagonist, a remarkable scholar named Muhammad ibn Musa al-Khwarizmi. Recognizing this huge societal need, he set out to create a highly practical guide. And the result, completed right around 820 CE, was a totally groundbreaking book called Kitab Al-Jabr wal Muqabala, which roughly translates to the compendious book on calculation by completion and balancing. Now, this wasn't just another math book, okay? It introduced an entirely new way of thinking, specifically designed to solve these everyday problems for anyone in administration or business.
Which brings us to Part 2, completion and balancing, the core concepts. So how exactly did this book tame the mathematical wilderness? Well, it comes down to two elegant, super fundamental concepts that actually form the title of the book itself. First, we have Al-Jabr, which essentially means restoring or completion. Imagine you had an equation with negative quantities. Al-Jabr is the process of moving those negative terms to the other side to make everything positive and just way easier to solve. Then you have Al-Muqabala, which means balancing. Think of it exactly like a physical balancing scale. If you have identical weights on both sides of the scale, you can take them off without tipping it, right? In math, this just means canceling identical equal quantities on both sides to simplify the equation. Put them together, and these two techniques form the absolute bedrock of algebraic problem solving. Moving to Part 3, organizing mathematical chaos and the 6 forms. Now, what's really interesting about this is how Al-Khwarizmi didn't just stop at giving out rules. He completely revolutionized math by categorizing equations instead of treating them all separately. See, because his system didn't use negative numbers or zero coefficients, he realized that every single algebraic problem could actually be converted into one of 6 standard forms before solving. We're talking squares equal roots, squares equal numbers, squares and roots equal numbers, squares and numbers equal roots, and roots and numbers equal squares. It's like a giant puzzle, but now you have the corner pieces. By converting any messy real-world problem into one of these 6 clean categories, you instantly knew exactly how to solve it. A total masterpiece of systematic organization. But Al-Khwarizmi was a phenomenal teacher. He knew that just giving people rules to memorize really wasn't enough. He wanted them to understand why it worked. So, showing pure genius, he combined arithmetic with geometry. He actually drew physical squares to represent squared numbers and rectangles to represent multiplication. He used visual geometric diagrams to literally show the completion of squares, proving his algebraic rules visually rather than just making his students blindly memorize abstract formulas. Now for Part 4, math for the real world and its practical applications. All this brilliant theory would be basically useless if it didn't help the people of 9th century Baghdad actually do their jobs. And this brilliantly illustrates how this book served as a daily survival guide for the Islamic world's economy and legal system. This math was built explicitly for real life. Merchants used it for calculating profit, loss, and currency exchange. For judges, it was an absolute lifesaver.
Islamic inheritance law required this incredibly precise division of estates among relatives, which meant super complicated fractions. Al-Khwarizmi's algebra produced fair, legally sound results every time. And surveyors, they used it to measure triangular and rectangular agricultural land for taxation.
On to part 5, no symbols, just words, and the mathematical language. Prepare yourself for a pretty mind-blowing reveal here.
Al-Khwarizmi managed to do all of this incredible mathematics without using a single modern math symbol. Seriously, no way. No plus sign, no minus sign, no equal sign, not even the letter x. An equation that we would instantly write as x squared plus 10x equals 39 was documented entirely in words. Every equation was explained in complete sentences, detailing each mathematical relationship in prose. While that might sound totally exhausting to us today, back then it made the book highly accessible to readers who were completely unfamiliar with abstract symbols.
Let's move to how this builds into his broader educational legacy. Al-Khwarizmi used a consistent 5-step learning process. Introduce the mathematical rule, explain the reasoning, solve an example step by step, present practical applications, and then reinforce with extra problems. Does that sound familiar? Well, it should. This 1,200-year-old teaching method perfectly matches the structure of modern math textbooks today. He wasn't just inventing a discipline, he was inventing exactly how to teach it.
Finally, part 6, the legacy of algebra and a 1,200-year echo. This single Arabic manuscript, a book literally written to solve everyday problems in 9th century Baghdad, ended up causing a monumental ripple effect that reshaped the entire world. First, the linguistic legacy. Remember that technique of completion, moving negative quantities to make them positive? The Arabic word for that was Al-Jabr. Over the centuries, as this text spread like wildfire, that specific word morphed into the name of the entire mathematical discipline. Yes, that is exactly where the modern English word algebra comes from. Mind-blowing, right? So the crucial point is visualizing this book's truly epic journey. It was completed in 820 CE in Baghdad. By the 12th century, its immense value was recognized way beyond the Islamic world, and it was translated into Latin for European scholars. It became the bedrock of medieval mathematics in universities across Europe. And today, in the modern era, those exact same principles are taught in classrooms globally. It took scattered, confusing numerical techniques and transformed them into a coherent scientific discipline. Which brings us to our final thought today. We live in a world completely governed by algorithms, engineering, and digital architecture, all of which absolutely require equations to function. So, how many of our modern technological conveniences secretly rely on the balanced equations of a 1,200-year-old manuscript? It's incredible to think about. Every single time you, or a student, or an engineer balances an equation today, you are echoing Al-Khwarizmi's genius. Mathematics is fundamentally a human story, and this book was for sure one of its greatest chapters. Thank you so much for joining me on this explainer, and keep looking for the hidden structures that shape our world.